We're looking at two problems tonight. Problem number one asks us to calculate the pH, the pOH, the H plus, the OH minus concentration of a sodium hydroxide solution, and the sodium hydroxide solution has a molarity of 4 times 10 to the negative third. Kind of important for you guys is the formulas we'll be using tonight are the ones right there. Now, just so you know, there are more than one way for you to get to the correct answer. Okay, there's more than one method that you can use to get to the final result, which is kind of cool. So although I'm presenting one way, just know that if you see a different way to get there, you're probably right, especially if you're getting the same answers. Now, the first thing I'm going to do is take from the problem. My problem gives me, I have a sodium hydroxide solution, and it has a molarity of 4 times 10 to the negative third. So that means my OH minus concentration is 4 times 10 to the negative third. Now I'm doing that because when OH, which is right over here, is going to hit the water, it's going to dissociate. Dissociate means breaks up. And so the Na is going to be split from the OH. And you're going to have 4 times 10 to the negative third ions of hydroxide OH. So that's where I got that from. And so what I've done is I've solved for the OH, or the hydroxide concentration. So that's one of the four things is taken care of. And I didn't even need a formula to do that. Alright dudes, next up we have the pOH. Now you could have gone a different route actually. You could have solved for the H plus using that formula right down there. I'm just going to go straight and calculate the pOH. And for the pOH, I'm grabbing the formula right there. pOH is a negative log of the OH ion concentration. And when we start doing the substitutions in here, I just substituted right here the ions concentration from the previous step. And when I do that, I find I have the pOH of 2.40. Awesome, dude. So right now, I've also now taken care of the pOH. Where do you want to go next? Well, we have to now solve for the pH and still the H plus ion concentration. The place I'm going next is to solve for the pH. And I'm going to use this formula right here. And the pH equals 14 minus the pOH. I just did a little rearrangement of it. When I do my substitution, the pH is 14 minus 2.4. And the pH is going to be equal to 11.6. Alright dude, so my pH is taken care of, and the last thing I'm going to do is now solve for the concentration of the hydrogen ion. Now, the one formula I did forget to put over here on the right hand side was this formula right here. I see I kind of doubled up on a formula in retrospect, but we're going to use this formula here. It's kind of called the inverse log, where I'm going to use 10 to the x equals the H plus ion concentration. Now, I'm going to do a little substitution. Instead of x, I'm going to use 10 to the negative pH. When I throw my substitution in there, I'm using this from the previous step, so 10 to the negative 11.6 is going to be equal to my hydrogen ion concentration, and that's going to be 2.51 times 10 to the negative 12th. Now, what do we got here, guys? Something that has a pOH that's kind of low means the solution is basic. So I have a low pOH. This means I have a basic solution. That's supported by the fact that my pH is actually 11.6, which is definitely a basic solution. The other thing I would look at here is that the hydrogen ion concentration has an exponent value of negative 12. That means the pH of it is probably going to be somewhere a little below that in the 11 range, and I'm supporting that with a pH of 11.6. Now, I do want to show you something else. We were solving for the hydrogen ion concentration. You know, we do have this relationship here, the H plus and the OH minus. When I multiply them together, I get 1 times 10 to the negative 14th. When I rearrange this equation, I could have done the H plus ion is going to be equal to 1 times 10 to the negative 14th divided by the hydroxide, and the hydroxide ion was up there. I'll use that 4 times 10 to the negative 3, and likewise you still would have ended up with an H ion concentration of 2.51 times 10 to the negative 12. So there are more than one way to do this. just a little reference for you guys. When I am mentioning the log, I am mentioning this button right there on my calculator. Your calculator should look somewhat similar. You know, it's not going to look exactly the same, but you should have a log button. Generally, when I'm solving for this right here, the 10 to the negative x, or I use the 10 to the negative pH, I'm actually going the shift button. Alright, so that's right, I need to press the shift button and then the log to get to that right there. And that's what I'm substituting in. Another important thing, when you're trying to press these negatives, you're not pressing the minus button. Typically on these calculators, you should find a negative button, and I have that right down there on mine. Last thing that's going to be important for you with your calculator is going to be using this button right here, EXP. Now, when I enter in this number, 1 times 10 to the negative 14th, in the calculator, I enter 1. I enter in mine the EXP button. Now, EXP means times 10. I would follow it up with negative 14. So just so you know, the EXP button can also be expressed on some calculators as the EE button, and also recently something like that, or maybe it's x times 10 to the n. One of those. Alright, so all of those mean the same thing, and they mean times 10. So please be familiar with your calculator. Alright, dudes, let's go on to the last problem. What I'd like you to do, if you could, is try the problem on your own. Okay, just try it on your own. You got nothing to lose. I'm going to show you what we're going